There are a couple of ways to attack these arc length problems. They want to know the length of the arc that goes from B to I to G. So the first thing I want to do is label this measure x, not the length of it, but the degree measure, because I need to know the degrees of that arc. So it's 360 minus the 150 degree arc here, which makes this a 110 degree arc. Sorry, a 210 degree arc. Well, I know that the circumference of the entire circle, if I want to do this piecemeal, the circumference of the entire circle is 2 times 12 times pi, which is 24 pi centimeters. But I don't want the entire circle, I just want this fraction of it. So I have some options. One is to say that the arc length that I'm looking for is the fraction of the circle I'm dealing with, 210 over 360, times the full circumference. And I just do this in my calculator, 210 over 360 times 24. It says leave it in terms of pi, so I don't want to times pi. And I end up with 210 divided by 360 times 24 is 14. Don't forget your pi, you haven't used that yet. So 14 pi centimeters. That's one way to do it. Now I'm going to erase that and show a different way. I still would need the same to find x. So x is 360 minus 150, which means x is 210 degrees. So arc measure over entire circumference equals, arc measure over entire circle measure equals arc length over entire circumference. And I can even show the work up here if I want to. Circumference is 2 times 12 times pi, so over 24 pi. Then I have it set up as a proportion, and I can cross multiply to solve that proportion. So 210 times 24 pi, but I don't want to use the pi, so 210 times 24 because it said to leave the pi in my answer. 210 times 24 is 5,040. So I get 5,040 pi equals 360 times the arc length. Then, to solve for the arc length, I would just divide both sides by 360. And 5,040 divided by 360 had better give us 14, and it does. So I have a couple of ways to attack that, but I can get to 14 pi centimeters either way. Now it tells me the length of this is 12 pi centimeters, and they want to find the diameter of the circle. This one's a little bit trickier. The measure of this arc, which I'm going to let be x, x is 2 times 80. Because this is an inscribed angle, it's half the measure of that intercepted arc. So this is a 160 degree arc. Again, if I choose the proportion way of doing this, I would say, well, 160 degrees compared to the entire circle of 360 degrees is the same thing as the arc length over the entire circumference. Now the problem is the circumference is the diameter times pi, and they want the diameter. So I could put c here, but I'm going to put diameter times pi. Something immediately happens. My pi's are going to cancel. So I could actually divide both of these by 10. So I end up with cross multiplying 16 times d equals 36 times 12, which is 432. Then I divide both sides by 16 to solve for d, and I end up with 27 centimeters. And I believe on my answer key I had said radius. I actually didn't read the problem carefully. It should be 27 centimeters for the diameter. If I did it the other way, without using the proportion, I would still have found the arc length here, the arc measure here, and I would have said, well, the arc length is the fraction of the circle that I'm looking at times the circumference, but that's just pi times the diameter. I could have then, if I wanted to, divided both sides by pi to get rid of the pi. I could have simplified the 16 over 360. If I did that, I'd end up with 8 over 18, which is 4 over 9. So I'd have had 12 equals 4/9 times the diameter. Multiply both sides by 9/4 to solve for D, and I still would have ended up with 27 centimeters for my diameter. Some people are finding the proportion way of doing it a little bit faster and easier though.